Okay, so now determinants and area. So I've got a post on this proving that the determinant is basically the area or area scale factor to do with vectors that like make a shape. So if we just take like a random matrix, let's say 1, 8, 5, 6. Now these two vectors or coordinates 1, 8 and 5, 6, if we plot them, so 1, 8 let's say is like here. So that's 1, 8, and if we draw the line over there, and then 5, 6, let's say somewhere here, 5, 6. Now, if we create like a parallelogram from this, or a quadrilateral, here, the area of this shape over here, actually let's just label it A. So the area is equal to the determinant of the matrix 1, 8, 5, 6. So like I said, I've got a post proving that the determinant and area are like the same thing, so you can go and check that out. But yeah, so there's actually area scale factors, so if we have matrix M and it's like transformed to like M dash another place, then the area scale factor is like the determinant of like the transformation matrix. So linking it back to the transformation matrices here, the determinant of this is just going to be AD minus BC, which is 2 times 2 minus 0, which is 4. And this is how much larger the area gets. So this little square over here, it had side lengths of 3. So the area was 3 squared, which was 9. Now this bigger square had side lengths of 6. So 6 squared is 36. The scale factor was 4, so 9 times 4 is 36. So the area of the square got 4 times bigger. So the determinant of the transformation matrix is the area scale factor. Right, so now let's try an exam question. So this one over here, the matrix P is given where P is 3, 2 and 2, 5, blah 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 blah. Okay, right, so part A. Determine the value of P. So we're told that the triangle T has vertices and we're given 3 coordinates, and this triangle is then transformed under the transformation matrix P, and the new area of the triangle is 15. So first let's draw triangle T. So because all the coordinates are positive, so we can just draw the positive x and y axes. Okay. Right, now we'll draw this to scale, so coordinate 1, 2 is going to be 1, 2. Coordinate 3, 2. And 2, 5. Okay, so this is the triangle T. Right, now we can draw a perpendicular line down there, and we can find the area of the triangle. So if we redraw it here, draw that down, perpendicular, bisector to the base. So the length of the base, we're going from, the y coordinate is staying the same, and it's just a horizontal line, so the length of the base is 2 because we're going from 1 to 3. Then the length of the perpendicular height is going to be the y direction, so from 2 to 5, which is 3. So area of a triangle, base times height over 2, so area is equal to 3 times 2 over 2, or 3 units squared. Now, the area of the image under T, under the linear transformation U, is 15. So like we did earlier, the transformation matrix P, the determinant of P is going to be the area scale factor. Now the area scale factor is going to be 5, because 15 is 3 times bigger than 5, so the triangle is getting 3 times bigger. So therefore, the determinant of P is equal to 5, which is 15 over 3. That means we know that the determinant of P is AD minus BC, which is going to be P times 3P, which is 3P squared, minus BC, which is going to be minus 2p, which is going to be plus 2p, and we just said this is equal to 5. Now we can make a quadratic. 3p squared plus 2p minus 5 is equal to 0. Now this factorizes to 3p plus 5 and p minus 1 equals 0. So what we get is p is equal to negative 5/3, or p equals 1. But we have to determine the value of p. Now if we look here, p is a positive constant. Minus 5/3 is not positive, so therefore it is not minus 5/3, as p is a positive constant. Therefore p is equal to 1. And if we check the mark scheme, here p is equal to 1 must reject p is equal to negative 5/3. Now that's all for today. Part B we'll get to probably in the next video, because we've got a transformation followed by another transformation. That's what's soon. So we'll come to part B and part C in a future video. Hope this was helpful. Bye bye.